Hello everyone, this is a video lecture for Pre-Calculus section 11.6, Polar Conics. This is the last section that we have in the class. This one is a notorious section. It's different. It's like the very last one. Honestly, some people just skip it. Sadly, I'm going to say sadly. Mainly because of time constraints or something or other. I hope that you don't. That's why we're doing it here together. And we're going to learn even this last section. Because it's on tests and stuff too, of course. I mean, you got to still learn it. I just wrote these two formulas for you. We have R is equal to ED divided by 1 plus or minus E times sine theta. And then R is equal to E times D plus or divided by 1 plus or minus E times cosine theta. That's E times sine or E times cosine. It's not like E sine or E cosine. They're actually multiplied. It's either one because it depends on directrix distances and all kind of stuff like that. So if you're going to be along the x-axis or y-axis or whatever. The main thing that you need to know is that one focus, or maybe sometimes your only focus, is at the pole, which is 0, 0. This is always. Okay? Let me just go ahead and show you a visual example. Let's say I have an ellipse, kind of like this here. And so this right here is one of my foci, and I guess one's way out here. But we're really just saying there's one of them at the origin, okay? And the directrix is going to be opposite of that. Your conic will never go through a directrix. Now, you might be wondering, well, how does an ellipse have a directrix? Well, I mean, everything's got a directrix, actually. We just don't really talk about it too much. Normally, we just say parabolas and stuff, but hyperbola directrix is somewhere over here between them. The directrix, again, is just never touched by the graph. And so here's another one. This is a parabola. Again, my focus right here. Always a focus at the pole. And then my directrix. So those are just different examples. They could be all over the place. But notice that we got x-axis versus y-axis. Here's another x-axis. The x and y axes tell us about the sine or cosine. Which one? So this is a y-axis. Y-axis centered at. I'm just going to say axis. So that's going to be an important aspect to decipher between which one of these guys we're going to use. So let me go and give you some formulas, I guess some definitions. E is your eccentricity. And you know what's funny? We were solving for eccentricity a lot in the last sections, but they never wanted it. So now we have it, and we're going to be using it. D is your directrix distance. The thing is that this is always positive. Always positive. And so I've seen in some books where they write it as D 1 plus or minus E cosine sine, something like that. That's one variation with the absolute value signs. I've even seen it with P, absolute value of P. They change that letter a lot. It's a 1 plus or minus. Blah, blah, blah. But basically, again, that's just going to be my directrix distance from the origin. So from the pole at 0, 0. Okay. Again, your sine or cosine is, it's about the axis. So again, a y-axis kind of polar equation, you're going to use sine. And if you were centered on the x-axis, it'll be a cosine. Okay. There's one last part. Notice that if you go back, we have a plus and minus right here. The plus and minus is actually important as per directrix direction. Kind of weird. This is the directrix direction. Directrix direction. So positive will be on the positive side, literally. So let's just do some examples, kind of piece them together. Right now we're going to take a lot of just components and stitch them together, and eventually we'll be doing our own thing here in just a minute. So they say this is an ellipse. They have an eccentricity of 5/6, but this tells you that it's an ellipse because it's less than 1. They say my directrix is at x equals 6. Now I'm going to specify in particular this is x equals a positive 6. Very important to see this stuff. So we have an e. That's pretty easy. X, we're going to use cosine. Positive, out of the plus and minus, we're going to use the positive. And then 6 is your d. Remember, it's absolute value. Okay. So if I had a -6, it would still be a 6. I think I have everything I ever needed. So r is equal to, again, ed, 1 plus or minus, e cosine theta. I'm using cosine because of the x right there. And I'm just going to fill in all the pieces. So I got 5/6. Hold on. Make it look a little bit better. 5/6. D is a 6. Divided by 1 plus or minus 5/6 cosine theta. They want you to include the r equals, I'm 90% sure. Because I have them all boxed in like that anyways. And if they say r equals and then a box, go ahead and type just whatever. But if they don't have an r equals, you definitely need it. I'm going to graph each one of these so we know what it looks like as we keep going. In particular here, so I have my directrix is at 6. 1, 2, 3, 4, 5, 6. It's my focus. I don't know exactly what's going on. It's going to be somewhere over here. Okay. An ellipse. Somewhere over here. Where is it? Where's its vertex and all that stuff? I don't know. Where's its center? I don't know. I mean, we can find these things from the equation, but I'm not really concerned about that right now. One last thing before I move on. This is not the WebAssign answer at all. If you go and get it wrong 3 times to see what they got, it is wild. They always make it look way complicated for no reason. This is a huge pet peeve of mine. They ignore the fact that there's always a 1 there. They put all kind of numbers all over the place. I'll tell you what it looks like. Here, I'll do my best. So the 6's cancel, give you a 5, right? But they just cannot have fractions, man. They cannot have fractions. And so they multiply both the top and bottom by 6. And so I bet that their answer looks a lot like that guy. I am not going to do that. It is so much harder taking what numbers you need from that rather than what we have here. It's literally laid out for you. E, D, E, cosine. Sorry, my final answer is a plus sign right there. I'm so sorry. I should have put a plus sign there. That I would rewind, but you're watching the whole video, aren't you? The answer is only a plus sign because, remember how we said, it was a plus. We said that. I don't know why I didn't put that. Sorry. That was totally my mistake. I'm just so used to the plus minus. Okay, sorry. So yeah, and there you go. So again, I'm trying to say that WebAssign answers are nice and simplified, and they don't mean anything at all for what we're going to be doing. Moving on. So 116005. I have a parabola, and they just say, hey, you're going to have a parabola. Okay. And they say we have a directrix of y equals positive 6. When you have a parabola, that means e is equal to 1. Literally just 1.0. That's a parabola. Y means that we're going to be using the sign. My plus sign means that we're going to use the plus sign, obviously. And then the 6 is my d. Again, absolute value is just positive 6. We should be able to just put everything together. So ed 1 plus e sine of theta, and there you go. You're done. You want to graph this thing where your focus is right here. Your directrix is at 6. 1, 2, 3, 4, 5, 6. And I'm guessing that your center is at 3, but that's just a guess. My vertex center is at 3 there. Next question. 11,6,007. Says that we have a hyperbola. My eccentricity is equal to 5, but that would tell me it's a hyperbola because it's more than 1. And then they say my directrix is at, and this is a very strange one, r is equal to 2 secant theta. Very weird. What this is in polar form, if you were to graph this on a calculator in polar form, it's actually a vertical line centered at x equals 2. What they're trying to say is this guy here is x equals a positive 2. I mean, it's literally the same thing. Saying this and saying that are the same thing. If you want to take the long road to find that, you go back a couple chapters to where we say, secant is 1 over cosine. Cosine is your x over r. The r's cancel. You get an x equals 2. Blah, blah, blah. So there you go. Well, now we're going to be using cosine for our final answer. Out of the plus and minus, we'll be using the plus sign here, and d is equal to 2. Obviously, we still have our e. So here's my final answer. E, d, 1 plus, and then e cosine theta. There's your answer. What does this look like? Again, there's your focus right here. My directrix is a positive 2, and your graph never touches that directrix. Now, it's not centered at 2. It's off center, so I did it injustice. It's probably somewhere over here, and your center's like there or something. I don't know. Again, we can find those other things later. I'm not really too concerned because they're not asking. When they ask, I'll do it. Not right now. 11,6,009. They say that we have a parabola. Again, that means e is equal to 1. I have a vertex. If we're talking vertex, I'm saying vertex center. At 8 comma pi over 2. And that's kind of like, what? Well, I got to graph this thing. This is actually an r theta. This is polar form. Remember, this is polar. So this is an angle of 90 degrees. So straight up, and then 8 distance. 1, 2, 3, 4, 5, 6, 7, 8. This is my vertex center. This is definitely always my focus. And so we got this guy here. Now remember that your directrix is always the same distance here and there. And that's going to be, this is some number. That's p, by the way. It's p. But not in this case. Remember directrix distance. D is the distance from directrix all the way to the focus. That's your d distance. This d distance here is actually 8 here. So this would be a 16. Kind of a weird thing there, okay? Also, if you wanted to write your directrix straight up, it's a y equals a positive 16. Y means it's, horizontal line. Positive 16 is up. There we go. So we have an e. I have sine. I have out of the plus and the minus, I'll be using a plus. And my d is equal to 16. Immediately, I can graph. I can write the answer. E d divided by 1 plus, not plus minus, plus e sine theta. We're done. Cool. Moving on. 11,6,011. They give me this time r is equal to 6 over 1 plus cosine theta, and they want to graph it, I'm pretty sure. So some things here. Notice that what's the number in front of the cosine? That's technically a 1. That's a 1 right there. And so my e is equal to 1. I said that ed is equal to 6. Well, I know that it's 1d is equal to 6. Therefore, d equals 6. A positive, well, it's always positive there. 6. Okay, so we got d. We got an e. Notice we got a plus sign. This is positive. And then we got cosine is an x equals blah, blah, blah. Let me take all 4 of those components and put them together, okay? So I got my e is equal to 1, whatever that means. Parabola, I guess you can say. Parabola. And then my directrix is x equals positive 6. You can see I got the x equals positive 6. And there's my e for parabola. Now I have everything I ever needed to graph this thing. 1, 2, 3, 4, 5, 6. There's my directrix. Always a focus right here. And so my center, I'm guessing, is at 3, and it does this because it's a parabola. Ta-da! Okay. 11, 6, 0, 1, 2. I've got r is equal to 2 over 2 minus 2 cosine theta. It's a classic WebAssigned kind of question where it just says, okay, now you figure it out, and they leave you in the dust. It's not very nice of them to do this. First off, everyone's got a 2, but that's not the thing to cancel necessarily, like just because it's a 2. I need this right here to be a 1. I always need this to be a 1. And when they don't do that, it's very annoying. So I am going to divide everything by 2. That means this dude, and this dude, every one of them. So I got 1, 1. That's a minus in this particular case. 1. Now, you might get a different randomization than me, and you might not have it cancel so nicely and all that. I don't know. Everyone gets different things. So just watch out, okay? I just need to get that guy into a 1. If you get fractions or whatever, that's fine. But I can tell you some stuff. I can say that e is equal to 1 looking right here. We have a negative. That's going to be interesting. ed is equal to 1. Well, I know that e is a 1, and so therefore d is equal to 1 also. And then cosine is saying it's going to be x equals whatever, blah, blah, blah. So I have an e is equal to 1. That means it's a parabola. And my directrix is going to be x equals a negative 1. So I'm using those other components there. Let me put this down. So negative 1 for my directrix, x, is my focus, and you know it's a parabola, and it's going to do this. It's actually right in the middle there is the halfway mark. Okay, cool. I don't know why on my paper here I did not draw a parabola. I drew something completely different. Well, I guess that happens. Okay, cool. I would ask if you have questions, but of course it's a recording. Next question. Let's keep moving. 11, 6, 0, 1, 6. So I have r is equal to 12 over 2 plus 3 cosine theta. Again, thank you WebAssign for not making it as easy as you could. I'm going to divide everything by the 2. So I got 12 over the 2, 2 over the 2, 3 over the 2. And I did that too because I really want a 1 down in the bottom. Everything else does not matter right now. I need to have that 1 down there. Okay. Well, I have an e is equal to 3 halves. This makes it a hyperbola because it's more than 1. ed is equal to 6. Well, I have 3 halves times d is equal to 6. When I move this over, I actually have 6 times 2/3. The 3's here are going to cancel. 2 times 2 is a 4. So we have d is equal to 4. Remember, that's always positive. That's something to note. But it could change my directrix. I'm just saying this number is always a positive regardless. This particular one is positive because it's right there. And we got an x equals da-da-da-da-da. So there, and, well, there. Okay. So let me just start putting it together. So e is equal to 3 halves. Again, that's hyperbola. My directrix. I don't think they're asking for this directrix stuff, but I'm telling you the way to do it is to do it this way here. Positive 4 distance. Positive 4. Remember, I'm not assuming that it's just, oh, that's a positive, so therefore it's positive. No. It has to tell me it's a positive for it to be a positive. So 1, 2, 3, 4 is my directrix. This is a hyperbola. My focus, I always have one focus right here. And I don't know where my center is exactly. It might be right here. It might be, somewhere else. It doesn't really matter. You pick this guy here, and you're good to go. So that's it. That's all I got there. So 11, 6, 017. I mean, we can do these all day long. Hopefully I'm teaching you something here at all this. Notice that we have a 1 right here. That's already a 1 there, so that's good. We have a 1, so that's a parabola. I think my handwriting is getting worse. What do you think? Yes. It's a negative. If you notice right there, we got a negative this time. It's a negative parabola. I got a y equals. And if you see here, this is ED is equal to 6. My E is a 1. Therefore, D equals 6. And so putting it all together, eccentricity is 1. My directrix is y equals a negative 6. Y equals negative 6. E was really simple. So drawing that, I actually got a, here we go, 1, 2, 3, 4, 5, 6. There's my directrix. Always a focus. It's a parabola in particular. So I think at 3 is where we're going to do this guy. And there we go. Gosh, that is probably the worst parabola ever. I'm just not used to parabolas right now. I'm used to other conics, apparently. I'm not going to waste your time. Close enough. This one, actually, I have something else for you. It says, find where the vertex is and find the directrix. Well, thankfully, this one's already done, because, well, we already made that. But what would be the vertex? Remember that they want r comma theta. This is different. It's not x comma y. I could say, oh, I know where it is. It's right down here at 0 comma negative 3. It's not 0 negative 3. It's actually going straight down. Notice that it's going down. How do you say down? 3 pi over 2. Again, that's basically 270 degrees. So I'm trying to say 270 degrees, which basically means down in polar land. Down. But how much down? 3 down. 3 distance down. This is just simply a distance. I don't know what to tell you. There you go. Next question. 116021. R is equal to 7 over 2 minus the cosine of theta. Do not like the fact that there's a 2 there, so I'm dividing everything by 2. And I see immediately E is equal to a 1/2. I have a negative, and it's going to be an x equals. This, by the way, this is an ellipse, because it's less than 1. And ED is equal to 7/2. But I know that my E is 1/2. It's interesting. Half of D equals half of 7. So D equals 7. Just a thought there. Sorry, it shifted a little bit. Okay, so let's put it all together. I got an eccentricity of 1/2. I have my directrix is x equals a negative 7. And they want you to graph it, of course. Ooh, they got a lot of stuff on this question. Apparently it's a big, big question. Oh, man, here we go. All right, so let's graph it before we keep going here. So we got 1, 2, 3, 4, 5, 6, 7. There's one of my foci. And it's going to go this way. I don't know how far. I don't know exactly what it looks like, but that's basically what's going on. Don't use my graph and say, oh, it's going to be a negative 4 over there. It's definitely touching at 4. No. I have no clue where it's going to be touching or crossing through or whatever. No clue. I just drew the best I got. But they're now going to ask for vertices. And I'm looking at the answers here, and I find that I'm, like, repeating myself or something. Oh, and they want the center. Oh my gosh. And also major and minor axes. Okay, well, here we go. So let me tell you how this works. They're going to want the center. They're going to want the vertices. And then they're going to want the major and minor axes. When I say major and minor axes, I'm meaning that 2 times business. 2 times the minor, blah, blah, blah. Okay. To do this, we need to plug in polar values for theta. That's going to be the big thing. If you remember, I'm going to redo this kind of like a unit circle right now. This right here is 0 degrees, or I guess 0 radians. This guy, as you keep ticking up, you're going to get pi over 2, 90 degrees. Over here, we got the pi, or again, 180. 3 pi over 2 as we keep going around and around. And then finally back here to 2 pi. Neato burrito. So what? Well, what actually is, it is important because my vertices are going to be right here and right here. Those are my vertices, okay? And they want these guys. They're located at 0 degrees and at 180 degrees. Again, 0 and pi. I know the theta value where they are located. This is helpful. This is helpful because what I'm going to do here is I need to find my R equals. Did they give it to me? Oh, they did. We'll just use theirs. I'm going to use my R equals. I'm going to plug in my theta values here, 0 and 180. Again, 0 and pi. And actually get the R values there. So I'm working on vertices right now. So I'm going to plug in the 7 divided by 2 minus cosine of 0. 0 radians. Well, cosine of 0 is a 1. 2 minus 1 is 1. So 7 over 1 means a 7. What I just made is a point, r theta, by the way, r theta, equal to, and so I had my radius is a 7, and my angle was a 0. That is, I mean, yes, 7 comma 0, you're thinking, well, you know, 7, 1, 2, 3, 4, 5, 6, 7 kind of thing. That's a true statement right now. It actually ends up being x and y the same thing right now, but not technically every time. So just, again, this is an r and theta. You know, happy days we found it over there, I guess. If you're misunderstanding my kind of apprehension, is that if you convert this over to x and y, it actually ends up being the same number. But that just, you don't need to know that. Don't go there. Don't go there. Okay, so that was my blue. Let's get the green over here. So I'm going to say green. I'm going to plug in now a pi. Or again, 180 if you're more comfortable with degrees. So cosine at pi is -1. This guy's a -1. 2 negatives, we get a positive. So 2 plus 1 is a 3. And so my point here, I'll say Q, just because it's funny. We got 7/3 comma pi, and that's my other vertex. So these guys are my vertices, the blue and the green. My center now, I'm doing it backwards kind of, but I mean, that's fine. My center is going to be in the center of those two. I guess you could say it's the average. But now, be careful. Over here, we got 7/3, and on this distance here is 7. And so we're not going to add them, divide by 2. Actually, you can see that this is technically a -7/3 because it's in the negative direction. This is a positive direction. We got more distance there. And so I want to find the average between those two there. And how I do it? Oh, I just added them? Oh, and then I subtracted. Yeah. Okay, sorry. I was... Sometimes I do kind of weird math on my notes and stuff like that. Yeah, that's okay. We got the same answer. Just verifying. Okay, so now we're going to average these two guys together to get my center. So -7/3. So add them, divide by 2, and you get, well, 7/3. And so my center is right here at +7/3. And so how do I list my center out? It's at 7/3 distance at the 0 angle. Again, yes, it's the same as x comma y in this particular case, but I don't want you to go in that direction. This is what they actually want. Phew. And then they finally want the major axes. Again, that's 2 times the major. And the minor axes, 2 times the minor. This is old school stuff. What I actually want to do to find this major in particular, I'm going to use a different color. I'm going to go back, and I want to find the distance from here all the way to here. Because that's what they're really looking for. This is the major axes. Major axis? Major axes? Whatever. Doesn't matter. Plural, singular. So basically that full distance. Well, we know that this distance here is 7/3. And we got this distance here, which is 7. So what I'm going to do is add them together, and that's my answer. So I'm going to say it's 7/3 plus 7, like straight up, calculator, and I get 28/3. So there's my major. How do I now find my minor? Well, this is an ellipse, so c squared is equal to major squared minus minor squared. We got a major. We can find c. C distance, again, is from the center to the focus. And so that distance there is technically the distance to the center right here. So c is equal to 7/3, just telling you ahead of time. So 7/3 squared is equal to 28/3. Actually, it's 28/3 is kind of interesting because this is 2 times major. Watch out. Got to divide it by 2 still. Square it, and then find your minor squared. So many technical things that could go wrong. And I'm tired of this pink color, so we're going to move these 2 over here. Major squared is now equal to 28/6 all squared minus 7/3 all squared. Lots of math, and I finally find my minor is equal to 7 over the square root of 3. Wow. Well, I mean, I'm just going to cut to it. I mean, basically, this is minor squared is 49/3, so when you square root both of them, there you go. Okay, so then minor axis is 2 times the minor. 2 times 7 over the square root of 3 is 14 over the square root of 3. Why do they keep asking for so much? Just to be annoying. Okay, last one. 11,6,025. R is equal to 8 over 1 plus 2 cosine theta. I'm going to decipher a lot of this immediately. I got an E is equal to 2. That makes a hyperbola. This is ED is equal to 8. Well, I know that E is equal to 2, so 2 times D is equal to 8. Divide by 2 on both sides, and you get 4. So D equals 4, E equals 2. Notice that we got a positive, so that's nice. And then we got X equals for that stuff. So E is equal to 2, Hyperbola Directrix is an X equals a positive 4. Actually, I think this is one of your answers that they want, so there you go. We can graph this immediately. So 1, 2, 3, 4, Directrix. This is a hyperbola, and again, one of the foci is always located there. Again, I don't know exactly where it's going through. I don't know where its center is or anything like that. I just know that it's going to look kind of like this guy. So don't say, oh, it's 2, because he just graphed it at 2. It's not 2. I don't know what it is, but it's not 2. Okay. So, let's go and find my vertices now. They want to do all that again. Remember that this is an X major, so I'm going to have it, I'm going to use the red just to kind of emphasize here. I'm going to have them at 0 radians, and I'm going to have it at 1, or at pi radians, 180. Now you're thinking, well, hold on, there's nothing over here, so how can you say it's that much? Well, it's weird because I'm pointed this way, and then I'm going to backtrack to get to it. I'm going to result in a negative value for R, yet pi radians. Very strange, I know. Just use these like last time. If it were a Y major stuff, you would go and use the pi over 2 and 3 pi over 2. But here, because it's X major, we're going to use 0 radians and pi radians. Putting them together, here we go. So theta is equal to 0 and pi. R of 0, I'm going to plug it in right there. There you go. So 8 divided by 1 plus 2 times cosine of 0. Cosine of 0 is 1, so we got 8/3 out of that. Therefore, I have one of my answers is 8/3, comma 0. That's one of my vertices. The other one, I'm going to plug in pi. Remember, we're going to get a negative number out of this, and that is okay. Remember, I told you that. Cosine of pi is actually -1. So 2 times -1 is -2, plus 1 is a -1. So we got 8 over -1, which is just going to be a -8, comma pi. See how I got that negative? I backtracked. So they're saying 8 for, oh. Did you see something kind of strange? So if you go back and look, where's the 8 distance? Is this an 8 distance right there? No way. This is a 4 distance. That can't be an 8. What this distance here is, this is my 8/3, whatever that is. It's a little bit more than 2. So there you go. The 8 is actually, I'm pointing this way, and I went all the way back to this guy. This is a distance of 8. That's an 8 distance there. Kind of interesting how that worked. I was not expecting that. But, oh, there you go. You got your 2 answers. Your center is going to be the average between the two. But it's kind of different and interesting here because we got negatives and all this other stuff. What's going on here? Let me use magenta here. So the center is somewhere around where the directrix is. Again, it's not where the directrix is. It's not literally 4, but it's going to be somewhere around there. Somewhere between 2 something and 8 something, okay? So it's somewhere in there. How do I find that distance? Well, notice, what if I take the average between these two guys straight up? Between 8/3 and the 8, just straight up. And then I should be able to find the middle between those two guys, right? Sorry, I kind of zoomed in there. So 8/3 plus the 8 divided by 2, just finding the average. And I found... Why do I always do it the long way here in my paper? Yeah, let me just make sure my calculator is going to give me the same answer twice here, okay? Yep, same answer. 16 over 3. And so then that's my center is at 16 over 3, comma 0. Again, that's an r theta. But there you go. And that is it. We are done with all of the lecture series. Thanks for hanging in there through all of this. I hope it's been helpful. And again, if you have any kind of questions, let me know. Thank you very much, and have a great day.